So on this floor model, they have a different design. Instead of being vertical, this is horizontal. So instead of the freezing chamber being upright, the dasher is located in a horizontal fashion, and it's just a design feature. Some companies like to have, prefer to have this style, and then you would close the door and add the ice cream from here. Another feature that, say if you were opening an ice cream store, is whether or not you would want this to be an air-cooled machine or a water-cooled machine. Now, an air-cooled literally means that the exhaust from the condenser is just spewed out into the room. Water-cooled, obviously, the condenser is being cooled down by water. Now, that might seem wasteful because you're using a resource that just literally goes down the drain. However, it really affects the environment in which the machine is being operated. Because if you're freezing ice cream, this chamber is going to be about minus 20 degrees. So if it's minus 20 in there, then that means the heat is coming out everywhere else. So if you're working in a small kitchen area, it could be very uncomfortable and also impede the optimal conditions for the machine to run because it will be overheated. The other thing that is always chosen with the different models is that you have, electrically speaking, single phase versus triple phase. Single phase, in very simple terms, is much like your household appliance. So you have a 3-prong plug and you use it. However, triple phase is a commercial level or a commercial electrical arrangement for machines. And what this does, this allows for more power with greater efficiency. So the same amount of electricity that goes through, that you use in triple phase, makes the motor run faster and makes it more efficient to run it. And usually in a commercial operation, you would prefer to have triple phase for this reason. Plus it operates heavy motors that are required on ice cream machines, especially for one this size. A very important consideration when you're making ice cream, of course, is the overrun. And in the discussion of this, we're going to first start talking about the mix and how that can influence the overrun, and then we'll talk about the machines. So ice cream, as you probably already know, does have a standard of identity. Okay. And you should have this poster available to you on the 414 website in Canvas. And you can see that if you have ice cream, anything within here has to have 10% milk fat, 20% milk solids, and a minimum weight of 4.5 pounds per gallon. And that 4.5 pounds per gallon is to really tell you that you have no more than 50% air per volume and 50% mix per volume. Okay, so you can't be over that. You can't be over 100% overrun. Otherwise, then it falls outside the realm of ice cream. And so you can see the different products that fall outside ice cream. First and foremost, you have to keep in mind that the air is being incorporated while it's being frozen. So anything that's a popsicle or some water ices are actually not ice cream, they're quiescently frozen confections. Popsicle is much easier to use. Frozen yogurt, soft serve, sherbet, even frozen custards, and actually most gelatos always fall out of the realm of ice cream because usually gelatos and many frozen custards and so forth don't have the milk fat. So there'll be 6% milk fat, or say in the case of sherbet, you have very low milk solids. And frozen yogurt can have a lower milk solids also, well the milk can, just depending on your formulation. But if you're doing frozen custard, which again can be ice cream, there is an additional standard of identity, and it has to contain at least 1.4% egg yolk solids. So very important to consider. And again, you can look at these other descriptions of sherbet, water ice, and soft syrup, etc. Basically, most of them don't have well-defined, or definitely not a standard of identity in the United States. The thing that makes gelato, I guess, enticing and really well accepted in the rest of the world is that because it's lower in fat and lower in milk solids, I personally think it really allows itself for flavors. So because you don't have that fat competing in your mouth to coat your mouth and so forth, any flavors are much brighter because of the gelato. So as you can see, the mix is absolutely going to dictate or help you overrun, or not help you overrun, because as you can see, if you have water ice and you don't have any milk proteins, well, there's nothing in there to make it foam, because basically ice cream is a frozen foam. Not kind of a tricky food system, but that's what makes it so interesting. So the other thing is, if you don't have a lot of fat, you can still make a very creamy product, and that's by decreasing the amount of air incorporated into the mix, or making a low overrun, such as with frozen custard. Because usually what you find about frozen custard is that it's very smooth and creamy because there's very little air, there's a lot of mix, and so you have this nice fat coating your tongue and so forth as you eat it. And if you just look at the machines, you can see why this is a dedicated frozen custard machine, because in a batch freezer, and in another part we do discuss the difference between continuous and batch, but in a batch, as you can see, there's no air being pumped in, there's no control. But what is kind of influencing the overrun in the machine is actually the amount of mix that you put into that chamber. So look how small this freezing chamber is versus a standard ice cream batch freezer. Okay, it's, I don't know, 10 times more. So you can see if your mix is up to here, you have all that air that can be incorporated into it, but it's very passive. Usually the overrun on this type of machine, and even on the vertical, is somewhere around 50 to 60%. So it's very difficult, because the air is not being forced through the mix. It's very difficult because these aren't pressurized chambers. It's very difficult to get that overrun very high. And up to 100% would be very difficult with this style. But you can see on the custard that you are obviously going to have a very low overrun, so you'll be in the 40 to 50% range. So again, mostly mix, less air.